there are over 30 kinds of stable diffusion samplers out there. What on earth are the differences between all these? And those super complicated names and codes, are they some kind of secret code from the AI universe? And the big question, how do you even pick the right sampler? Well, don't worry. This video today is like your trusty guide, and let's dive into the wacky world of samplers. We're gonna sort these jam-packed samplers into 3 groups. First up, we've got the old school ones from the early days. Then, there are the DPM samplers that dropped in 2022. And lastly, the newbies that came out in 2023. Now, out of these 30 samplers, a bunch are either ancient history, or just not popular cause they don't cut it. So, we'll give those the sampler. And hey, here's the deal. This tutorial is all about picking samplers with speed in mind, to save your graphics card some grief. But if you're rocking a Tensor, no sweat. You've got that Tensor graphics card to handle whatever you throw at it. Among the old-school algorithms, DDIM and PLMS were the early followers of Stable Diffusion, but now they're past and can be ditched without a second thought. Euler, Hune, and LMS are the classic ones. Honestly, there's not a huge gap between them. Euler is the go-to choice for most, as it's straightforward and less error-prone. Hune is like Euler's fancier sibling, offering better image quality, but at the cost of being twice as sluggish. LMS, a linear multi-step method, is about as fast as Euler, but it's more likely to cough up wonky images. So, we'll just hold on to Euler and Euler A. Now, what's the deal with that A? Well, E-sampler with an A is the ancestral sampler. The images it spits out don't converge. What's that mean? Just peek at a couple of pictures. Without convergence, the randomness in the image generated at each denoising step is off the charts. With convergence, the denoised image will eventually settle into a fixed look. The plus side of convergence is a more stable and expected image. The beauty of non-convergence, it throws in more randomness and detail. So, pick your sampler based on what you're after. Next up is the DPM algorithm. Most of the stable diffusion algorithms fall into the DPM category and are super popular. But first, let's nick some of the less common samplers. DPM fast is a no-go as it hardly ever churns out decent quality images. The DPM adaptive sampler is a bit of an oddball. It couldn't care less about the sampling steps we set, and just does its own thing when rendering pictures, which takes forever. So, that one's out too. Then there are all the DPM2 algorithms. They're the second-gen DPMs. Sure, the image quality got a boost, but the processing time doubles. Turns out, we can just use the first-gen DPM algorithms and bump up the sampling steps a bit to get a similar effect. Alright, next thing you'll notice is that there are some samplers with the same name, but have Keras tacked on at the end. Compared to the original algorithm, these Keras versions have way less noise after around 8 steps of sampling. What does that mean for you? Well, it means you can get sharp, clear images with fewer sampling steps. So, our plan is to just hold onto the algorithms with Keras, and just like before, the algorithm with Hune is about half as slow as the one with Keras. Slow is no good, so we can give the algorithm with Hune the sampler too. The algorithms left for you to see are DPM plus 2S and DPM plus 2M. Now, here's what those letters mean. The 2S actually stands for a single-step algorithm, while the 2M represents a multi-step algorithm that throws in some extra info transmission between adjacent layers. The 2M is like an upgraded version of the 2S. So, since we've got the better one already, we can just wave goodbye to the 2S as well. Alright, at this point, the samplers that are left are the ones we commonly use in our daily work. Among them, DPM++ 2M Keras is the sampler that gets our highest recommendation. Why's that? Well, it's got a whole bunch of great perks. The output effect it delivers is really nice, it works at a pretty fast speed, and on top of that, it's a convergent algorithm, which means the images it generates will tend to stabilize and meet our expectations quite well. Now, let's talk about DPM++ SDE Keras. This one's a bit different as it's based on a stochastic differential equation algorithm. And because of that, it's not convergent. If you don't pair it with a multi-step algorithm, its generation speed can be painfully slow. But don't let that put you off completely, because the images it can create are really excellent. Generally speaking, when you're looking to generate realistic images and you've got a high demand for image quality, this is the sampler you'll want to choose. Finally, there's DPM++2 MSDE Keras. Compared to SDE Keras, it's faster, which is definitely a plus. Plus, there's an exponential algorithm added to it later on. This little addition has a cool effect. It makes the image look softer, and also tidies up the background, giving the whole picture a really nice and clean look. The 3M algorithm has the same speed as the 2M algorithm, but here's the catch: it demands more sampling steps. However, when the number of sampling steps goes above 30 and you lower the CFG value appropriately, the image generation effect turns out to be better. So, if you're planning to use more than 30 sampling steps, this sampler could be a good choice for you. Lastly, UNIPC and Restart are samplers from the new school bunch. UNIPC is pretty nifty, as it can whip up a usable image in roughly 10 steps. And then there's Restart, which is equally impressive. It can churn out a good image with even fewer steps than UNIPC, though it does come at the cost of being a bit slower in terms of speed. Alright then, that's our introduction to the common samplers. Hope it's been useful for you. If you found this video helpful, we'd really appreciate it if you could give it a thumbs up and hit that follow button. Looking forward to seeing you next time.